Running a small data center is one thing. Running one at scale is where the real pain starts. As the environment grows, applications multiply, and every change touches VLANs, ACLs, trunks, and firewall rules, the network gets harder to manage fast. That's where Cisco ACI comes in. It shifts you from box by box configuration to a policy based operating model. In this video, we'll build a clear mental model for Cisco ACI, why it exists, how the architecture fits together, and how the policy model changes operations. You'll see what the fabric is, how the main parts work together, and why policy changes the way you run the network. We'll keep this practical and stay focused on the architecture and the operating model. The goal is to make ACI feel practical, grounded, and useful, especially if you're learning it as an engineer. Once that foundation clicks, the rest of the video and the deeper dives later in the series will make a lot more sense. In a traditional data center, the network carries years of exceptions and layered changes. Policies get spread across switch configs, firewall rules, spreadsheets, and whatever the team still remembers. Even a simple app rollout can mean extending VLANs, changing ports, updating gateways, and coordinating security across multiple network platforms. Once a change touches multiple systems, consistency starts to slip. Two engineers can be aiming for the same outcome and still implement it a little differently. Two environments can be meant to match exactly and still drift, just because each one was configured a little differently. The result is slower deployments, harder troubleshooting, and constant friction between what app needs and what the network actually allows. Cisco ACI is Cisco's application-centric model for the data center. The key idea is simple. You define connectivity and security around application intent, not individual device commands. At the center of that model is APIC. It's the controller cluster where you define policy, manage the fabric, and push that intent into the environment from one place. Underneath that, the fabric uses a spine leaf topology. Leaves connect endpoints. Spines handle high-speed forwarding across the fabric. The result is a design built for predictable east-west scale. When people talk about ACI, it helps to think about three layers at once: the physical fabric, the controller model, and the policy model. That's why ACI is more than just a switching topology. It's an operating model built on top of the network. At its core, ACI is a framework for describing, enforcing, and controlling how the data center should behave. Let's look at the hardware side. Endpoints like servers, hypervisors, and service devices connect to the leaf switches, not straight to the spines. Leaves are where policy gets enforced for connected endpoints. They're also where the fabric meets the workloads you actually care about. Spines don't connect directly to endpoints. Their job is fabric transport, carrying traffic between leaves. They provide fast, highly available transport between leaves, so any leaf can reach any other leaf in a predictable way. One key distinction is that APIC controllers aren't in the data path. They control and program the fabric, but production traffic doesn't flow through them. APIC manages and programs policy, but actual packet forwarding still happens in the switches. In a leaf spine topology, traffic between endpoints on different leaves typically goes leaf to spine to leaf. That gives you a consistent hop pattern even as the fabric grows. Physically, it's clean and easy to reason about. Here's the physical recap. Leaves connect the workloads, spines interconnect the fabric, and APIC gives you centralized policy and management. With that in place, we can move to the logical model. This is where many engineers get stuck because ACI introduces a different way to describe the network. A tenant is the top-level container that holds the networking and policy object for an application, environment, or customer. Inside it, VRFs handle layer 3 segmentation, bridge domains define the layer 2 context, application profiles organize components, endpoint groups group endpoints by policy, and contracts control which groups can communicate. Here's the key idea. In ACI, policy is the starting point, not something added later. ACI gives you objects that represent application intent, then maps those objects to how the fabric should behave. This is where ACI changes operations. In the old model, you show intent by touching many separate settings. In ACI, you define the intent more directly. In ACI, you start with the application and work outward from there. You define endpoint groups, describe how they should connect, and apply policy at the model level instead of switch by switch. Let's make that concrete with a simple example. Deploying a new application tier. In a traditional setup, that usually means coordinating across teams and translating one requirement into many device-level changes. With ACI, the engineer is more often defining which groups can talk, what belongs together, and where policy should apply. That doesn't remove engineering judgment, it shifts that judgment toward policy design. The abstraction level is higher, so repeatability and consistency come from the model instead of manual repetition. So, the real win is not just fewer settings to touch. It's a cleaner, faster way to turn application intent into enforced network behavior. Let's make this concrete with a classic three-tier application. Picture a web tier, an app tier, and a database tier spread across the fabric. Instead of starting with ports and VLAN trunks, you model those tiers as separate endpoint groups based on their role in the application. Then you use contracts to define allowed communication. The web tier can consume services from the app tier, and the app tier can reach the database under clearly defined rules. That means the policy is describing business intent directly, not just low-level network mechanics. Public front-end here, application logic there, protected data there, with the relationships between them made explicit. When new endpoints join the right group, they inherit the intended connectivity model automatically. That's a big reason operations scale better and feel less ad hoc. ACI isn't magic. It's a powerful abstraction, but the fabric still has to learn, classify, forward, and sometimes route packets. The fabric learns endpoints, applies policy in context, and segmentation still depends on understanding layer 2 and layer 3 behavior. Contracts don't replace networking fundamentals, they build policy on top of them. So if traffic fails, you still need to work through endpoint location, policy scope, forwarding decisions, and where the packet is actually handled. The best ACI engineers hold both views at once. They think in high-level policy and underlying network mechanics at the same time. A common myth is that ACI removes the need to understand routing, switching, and segmentation. It doesn't. Another myth is that ACI is just SDN marketing. In practice, it gives you a real architecture, object model, and policy framework that changes how operations run. Early on, engineers often struggle because they try to map every ACI object directly to a traditional construct and expect a one-to-one match. A better approach is to learn what problem each object solves in the model, then connect it back to familiar networking behavior. Once you stop asking which command replaces which, ACI gets much easier to reason about. If you step back, ACI gives you real operational advantages. Policy is modeled once, applied consistently, and easier to scale. It also makes repeatable application patterns easier to roll out because the model is built to be reused. That can speed up deployments and reduce policy drift, especially when multiple teams are touching the environment. The trade-off is the learning curve. To run ACI well, you need a strong mental model, not just familiarity with the interface. If this first video gave you the right lens, remember this. ACI is a fabric architecture plus a policy model that lets you express application intent clearly at scale. In the next videos, we'll go deeper into fabric architecture, policy objects, contracts, forwarding behavior, L3 out, day 2 operations, troubleshooting, and multi-site design. If you want the practical details, keep going with the series. If you want ACI to feel intuitive instead of abstract, keep watching the next videos in the series. That's where the model really starts to click.